Hello students, so this is your Pallavi ma'am. So this video is under the K-CET and the NEET chemistry series, okay, and I think we have completed some parts of a solid state and some parts of a haloalkanes and the haloarenes, and here about the solution chapter we will going to discuss. As I mentioned, what is the weightage of the chapter, so you could check my previous video, weightage of each chapter, okay. And here for the solution for your CET and the NEET exam, you will going to get 2 marks, like 2 questions compulsory, okay. 1 or 2 questions compulsory will appear, okay. And on what concept the questions will appear, that I have mentioned here, okay. So like molality, molarity, mole fraction, ideal and the non-ideal solution, example of those ideal and the non-ideal with a positive and the negative deviation, and the graph that we have to go through, vapor pressure, Kb and the Kf values with a formula we need to concentrate, and the I factor. Here we'll just go through some of the shortcut tricks, okay, and the want of factor, okay, what is the value for the dissociation, association, and some of the those all we're going to discuss, and TB and TF, boiling point and the freezing point, okay, on what factors it depends, those all, as well as osmosis and the osmotic pressure. So among these I'm going to concentrate, and later once we complete all these, the shortcut tricks and everything, we will concentrate on the questions that appeared from this chapter in the previous years, okay. So let us start with the first part, that is molality, molarity and the mole fraction. Yes students, see here, molarity and the molality, these two are very important concepts, okay. Here molarity and molality, okay, where the molarity is represented by capital M and molality is represented by small m. Then what exactly this molarity, molality means? These are nothing but the concentration terms, like how we measure water in a volume, how we measure the solid substance, like maybe a rice or whatever the cereals we're going to bring, okay. So those we're going to measure them in a kg, like this. When we need to prepare some of the solution in a laboratory, okay, when we're going to prepare a solution in a standard way or in a standard method, a particular weight of the substance plays a very important role. So for that reason we can't measure those values in case of a kg like that, okay, ton like that, okay. So these are like a concentration terms. It will explain how much amount of the solute need to be taken and dissolved in a definite quantity of a solvent, so that a particular concentration of a solution could be prepared. That is what the molarity, molality, and some other terms also are there. I have taken these two, which are very important, okay. So simple way I could say molarity and the molality are the concentration terms. Here till we complete the solution chapter, these are very important, okay. W2, whether it might be a capital or small, you could take. W2 is always the weight or mass of a solute. 2 means solute, 1 means solvent. Or else you can take in another way, like B means solute, A means solvent. Okay, here I have taken W2, weight or mass of the solute. Okay, W1 will be always the weight of a solvent. M2, capital M2 is the molar mass of the solute. You know how to find out the molar mass. Okay, I hope that I'll explain. And capital M1 is molar mass of the solvent. Okay, 2 means the solute, 1 means the solvent. M means, capital M means molar mass. Okay, so these 4 terms are very important. You have to remember till we complete the solution chapter. The solution is prepared. It is the number of moles of the solute. Definite number of moles of the solute is dissolved in a 1 liter of the solution. This is the standard, that is 1 liter of the solution. Okay, take a definite number of solute, okay, and dissolve that in a 1 liter. That gives a particular molar substance. Similarly, molality is nothing but number of moles of the solute. Again, I am going to take a different number of moles of a solute, but instead of 1 liter, I am going to dissolve that in a 1 kg of the solvent. solvent. Okay, solvent is a liquid. 1 kg of the solvent, either water or any other solvent. Okay, so here liter, here we are going to measure a solvent in a kg. Okay, these are the standard formula. Now, what do you mean by this N? N is nothing but a number of moles. Okay, how are we going to find out the number of moles? We have a standard equation. Number of moles is equal to weight of the solute by molar mass of the solute. Okay, solute is nothing but a solid substance usually. That doesn't mean always it should be a solid. Instead of that, we can take a liquid like that. Okay, so number of moles is equal to weight of the solute divided by molar mass of the solute. Okay, now substitute this N value in both the equation. Okay, M is equal to, in place of N, W2 divided by M2 into volume as it is. Okay, similarly molality is equal to, in place of N, substitute these two values, W2 by M2 into W1. Okay, so as I mentioned, 2 always it is a solute, 1 always is a solvent. Okay, these are like a standard equation. Now we have a definite volume like 1 liter. Similarly, definite weight of a solvent like 1 kg. If I substitute that 1 kg and 1 liter here, molarity is equal to W2 into 1000 by M2 into V. Okay, W2 into 1000 by 1000, 1 liter is equal to like 1000 ml. So in that way I have substituted 1000 ml. Okay, M2 into V. This is a standard equation. How this 1000 came to the numerator? We have V divided by 1000. Okay, 1000 will move to the numerator. So these two are W2 into 1000 by M2 into W1. Both the equations are same. This is how you have to remember. Both the equations are same. Both the formula are same. In case of molarity, V comes over here. In case of molality, W1 comes over here. Okay, that is how you have to remember. Now, some of the question might appear based on this one. Molarity is temperature dependent. Means the molarity of the solution changes with the temperature. Okay, if the temperature increases, the molarity may change because we are taking the solution in a volume. Okay, so as the temperature increases or decreases, volume varies. Okay, volume may increase or decrease. So the SI unit or the unit for the molarity is mole per liter. Quite simple. Number of moles is mole and volume is in a liter. So mole per liter is a standard unit for the molarity. Similarly, molality is temperature independent. Means with a change in temperature, the molality of the solution or the concentration that is measured in a molality or weight of the solvent is taken in a kg will not change with a change in temperature. It is because we have taken the solution solvent in a weight terms, where the weight does not depend on the temperature. As the temperature changes, weight does not changes, but the volume will change. Okay, and the SI unit is mole per kg. Okay, mole per kg, mole per liter. Quite simple. So these all points you have to remember. Okay, now the question appears, how exactly molarity solution will be prepared? Okay, so simple example I am going to take. See, in a laboratory I need to prepare now 2 molar sodium hydroxide solution. I need to prepare 2 molar sodium hydroxide solution for the 500 ml, not 1000 ml, for the 500 ml. See, I have to prepare a sodium hydroxide solution of how much molarity, how much concentration, 2 molar. For how much volume I need to prepare 500 ml. Then how much weight of the sodium hydroxide I need to take. That we have to calculate. So we have a standard formula here, that is M is equal to N by V. Right? Okay. So here the number of moles of the solute is not given directly. 2 molar means the molarity is given. Okay, so in such case, see, I am going to use the formula M is equal to, N means what? The weight of the solute divided by molar mass of the solute. Okay, V as it is. Okay, V by 1000 will going to write. Okay, V means the volume that they have given. Standard is 1000 according to the formula. So it becomes M is equal to W2, 1000 will move to the numerator, M2 into V. Now, what do you need to calculate? The weight of the solute that I need to take in order to prepare 2 molar sodium hydroxide for 500 ml. So here molarity you know, molar mass of the solute you should calculate, volume is given for 500 ml we are preparing, only thing is W2, how much weight of sodium hydroxide I need to add. So keep W2 in there only and transfer all the values, it becomes W2 is equal to M. So what is the molarity you need to prepare? 2 molarity of a solution you need to prepare. M2 is molar mass of the solute. Solute here is sodium hydroxide. Molecular mass you need to find out means sodium atomic weight is 23. Okay. Oxygen is 16. Hydrogen is 1. So it gives how much? 40. So 40 is the molar mass of the solute for how much volume we are preparing for 500 ml divided by 1000 is equal to W2. So it is to the, so 40 W2 means you need to take 40 gram of a, we need to take 40 gram of, so we need to take 40 gram of a sodium hydroxide, okay, and that is added to the 500 ml of water, that gives 2 molarity of the solution. This is how you know we're going to calculate. Okay, if you know the terms very easily you can calculate. Now a simple question, 2 molarity NaOH is equal to how much moles? 2 molarity of NaOH is equal to how many moles? Okay, even 500 ml volume is given. Quite simple, within a minute you can do. We have the formula M is equal to N by V. Molarity is given 2. Number of moles you have to calculate. V is 500. Okay, so you can transfer here 2 into 500 is equal to N. So 1000. Quite simple, right? So this is how you need to calculate the number of moles and the molarity of a given substance. If you know this formula, it is very easy to calculate either the number of moles as well, or the volume as well, or the molarity, or the weight of the solute, molar mass of the solute, volume. Okay, these are very important terms. Again repeating, molarity is a temperature dependent, molality is temperature independent. So this is about the molarity and the molality. Okay, and here is a simple formula where the relation between molarity and the molality, relationship between molarity and the molality is molality is equal to molarity into 1000 divided by density into 1000 minus molarity into molar mass of the solute. So this formula you have to remember. These 3 formula are very important. This one and this one. This is the relationship between the molality and the molarity. If for example a question might appear, if the molarity is given through which you need to find out the molality, you can apply the direct formula. Okay, density means the given solvent, whichever might be. If water means you are going to substitute 1 over here, like that. Okay, the value will be given, you have to use the formula and you have to substitute. So this is about molarity, molality and the relationship between molarity and the molality. So similarly there comes one more concentration terms, that is mole fraction, represented by X, which is simply a number, it don't have any unit over here. Okay, mole fraction X. So here again you have to remember N1. N is nothing but a number of moles. 1 is solvent, 2 is solute. Again I am repeating. Okay, now what exactly mole fraction is that? I have a solution, for example. Okay, I have taken a water. In this water, what I am going to add? I am going to add sugar plus I am going to add salt. A simple example I have taken. So water is around 500 ml, let us think. Okay, so in this I have added sugar and the salt of a definite quantity. Okay, that gives a solution. Now In this 500 ml of a solution, what is the fraction of the sugar that is present? How many moles of the sugar are present in a total solution? Okay. Similarly, in a given solution, how many mole or what is the fraction of a salt that is present in the total moles of the solution? For example, the combined one, I'll take sugar per salt. Let us take, I have taken 5 mole. Not individually, by combining 5 moles of a sugar salt is mixed to the 500 ml of water. In this, how many moles of sugar is participating? Okay, what is the fraction of a sugar that is present? Similarly, what is the fraction of a salt present in a total volume? Okay, out of 5 mole of a 5 mole of a solute, what is the number of moles of a sugar? What is the number of moles of the salt? That is nothing but the mole fraction. Okay. So here, mole fraction of a particular solute. So which solute we need to find out is equal to moles of the solute divided by total moles of the solution. The moles of the solute and total moles of the solution. If we substitute this value, you will going to get. Okay. That is given by N2. N is nothing but a number of moles. 2 is nothing but a solute. Moles of the solute divided by total number of moles of the solution. N1 plus N2. If I want to find out the number of moles of solvent, N1 comes over here. So this is the standard formula. And one point you have to remember, you can apply in some of the numericals that have been given in an exam. Number of moles of the solute plus number of moles of the solute always equal to 1. It's standard value. Total number of moles of the mole fraction of the solute and the solvent, it's a standard value, that is 1. Okay. So for example, if I want to find out the X of a solvent, the mole fraction of a solvent, and I know the mole fraction of a solute, so I'm going to do 1 minus X moles of a solute. That is how you can find out. So you have to remember, mole fraction of a solute plus mole fraction of a solvent is equal to 1 always. So these are the 3 terms, molarity, molality and the mole fraction, on which repeatedly the question might appear for your competitive exam.